The minimum size of a tap conductor connected to a circuit disconnect is based on the requirements of the National Electrical Code, or NEC. For a tap conductor supplying a branch circuit, the minimum size is determined by the ampacity of the branch circuit and the distance between the tap and the overcurrent device protecting the branch circuit. The NEC provides tables for determining the minimum size of tap conductors based on these factors. The NEC does not require that a tap conductor connected to an AC disconnect be fed directly from the service entrance. However, there are certain conditions that must be met in order to tap an AC disconnect fed from 6-2 Romex. The tap conductor must be sized according to the NEC requirements. The tap must be made with a listed connector or splicing device suitable for the size and type of conductors involved. The tap connection must be enclosed in an approved electrical box or enclosure. The total load connected to the AC disconnect, including the tap, must not exceed the ampacity of the disconnect. There are advantages and disadvantages of tapping an AC disconnect. Firstly, consider the convenience. Tapping allows for easy connection of additional branch circuits or equipment without having to run a new circuit from the service entrance. Secondly, there is cost effectiveness. Tapping can save time and materials compared to running a new circuit. There are also disadvantages. Firstly, there are safety concerns. If the tap is not properly sized or installed, it could create a safety hazard due to overloading or overheating. Secondly, there is reduced current carrying capacity. The tap conductor will reduce the current carrying capacity of the AC disconnect. Thirdly, there is potential for nuisance tripping. The tap may cause the AC disconnect to trip prematurely if the total load exceeds the disconnect's ampacity. While it is possible to tap an AC disconnect fed from 6-2 Romex, it is generally recommended to run a new circuit from the service entrance for additional loads. This ensures that the circuit is properly sized and protected, and it eliminates any potential safety concerns or performance issues associated with tapping the AC disconnect. When considering the minimum size of a circuit tap, several factors come into play, all rooted in ensuring electrical safety and code compliance. The National Electrical Code, NEC, serves as the primary guideline. The NEC specifies requirements based on the tap conductor's purpose, its length, and the overcurrent protection of the main circuit it's tapping into. The key is to protect the tap conductor itself. Firstly, consider the tap conductor's ampacity. This must be sufficient for the load it will carry. However, it also needs to be protected against overcurrent. The NEC addresses this through various rules depending on the tap's length. If the tap conductor is relatively short, specific rules allow its ampacity to be less than the main circuit's overcurrent protection, provided certain conditions are met. Secondly, consider the 10-foot tap rule. This allows the tap conductor to be 10 feet or less in length without requiring it to have an ampacity as high as the main circuit's overcurrent protection. The tap conductor's ampacity must be at least 1/10 of the overcurrent device protecting the main circuit. The tap conductor must terminate in a single overcurrent device rated to protect the tap conductor's ampacity. The tap conductor must be installed in a raceway if it leaves the enclosure. Thirdly, consider the 25-foot tap rule. This allows for a longer tap up to 25 feet under stricter conditions. The tap conductor's ampacity must be at least 1/3 of the overcurrent device protecting the main circuit. The tap conductors must be protected from physical damage and enclosed in a raceway. The tap must terminate in a single circuit breaker or a set of fuses rated for the tap conductor's ampacity. Fourthly, consider transformer taps. When tapping the secondary side of a transformer, the rules are different. The tap conductor's ampacity must be at least 1/3 of the overcurrent device protecting the primary side of the transformer multiplied by the transformer's primary to secondary voltage ratio. The tap conductor must terminate in a single overcurrent device rated to protect the tap conductor's ampacity. The total length of the tap conductors cannot exceed 25 feet. Fifthly, consider conductor size. The actual conductor size corresponding to the calculated ampacity will depend on the conductor's material, insulation type, and installation conditions. NEC Table 310.16 provides ampacities for various conductors under specific conditions. It's crucial to use the correct ampacity table based on these factors. In the scenario of tapping an AC disconnect fed from 6-2 Romex, you must carefully evaluate whether this is permissible and safe according to the NEC. 6-2 Romex typically implies a copper conductor with a size that carries a specific ampacity, and the 2 indicates the number of current carrying conductors. Here's a detailed breakdown. Firstly, ampacity of 6-2 Romex. 6 AWG copper conductors with type NMB insulation, commonly known as Romex, typically have an ampacity of 55 amps, according to NEC table 310.16, assuming an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit, and no more than 3 current carrying conductors in a raceway or cable. Secondly, NEC compliance. The NEC doesn't explicitly prohibit tapping an AC disconnect, but it sets stringent rules to ensure safety and proper operation. The primary concern is that the tap doesn't overload the existing circuit or create unsafe conditions. Thirdly, tap conductor sizing. Any tap conductor must be sized according to NEC guidelines based on its length and the overcurrent protection of the main circuit. The tap conductor's ampacity must be adequate for the load it will serve. If the tap is short, the 10-foot or 25-foot tap rules might apply, but these have specific requirements as previously outlined. Fourthly, overcurrent protection. The tap conductor must be protected by an overcurrent device, such as a circuit breaker or fuses, sized appropriately for its ampacity. This protects the tap conductor from overload and short-circuit conditions. Fifthly, connection methods. The tap connection must be made using listed and approved connectors suitable for the conductor sizes and types being joined. Wire nuts, terminal blocks, or other approved splicing methods are acceptable. The connection must be secure and properly insulated to prevent shorts and ground faults. Sixthly, enclosure requirements. All electrical connections must be housed in an approved electrical box or enclosure. This protects the connections from physical damage and provides a barrier against accidental contact. The enclosure must be properly grounded. Seventhly, load calculations. The total load connected to the AC disconnect, including the tap, must not exceed the disconnect's ampacity. It's crucial to perform a load calculation to ensure that the circuit can handle the additional load without overloading. Eighthly, Romex limitations. Romex, or Type NMB cable, has limitations on its use. It is typically used in dry locations and must be protected from physical damage. It's not suitable for direct burial or for use in wet or damp locations unless specifically listed for that purpose. Ninthly, alternatives. If tapping the AC disconnect poses challenges or raises concerns about NEC compliance or safety, consider running a new circuit from the service panel. This ensures that the new circuit is properly sized and protected and that it doesn't overload the existing circuit. Tenthly, local codes and inspections. Always check with local electrical codes and regulations, as they may have additional requirements or restrictions beyond the NEC. It's also advisable to have the work inspected by a qualified electrical inspector to ensure compliance and safety. Advantages of tapping an AC disconnect include convenience and cost savings. Tapping can be more convenient than running a new circuit from the service panel, especially if the disconnect is located close to the desired load. Tapping can also save time and materials compared to running a new circuit, reducing the overall cost of the project. Disadvantages of tapping an AC disconnect include safety concerns, reduced current carrying capacity, and potential for nuisance tripping. If the tap is not properly sized or installed, it can create safety hazards due to overloading or overheating. This can lead to fires or electrical shocks. The tap conductor will reduce the current carrying capacity of the AC disconnect, potentially limiting its ability to handle other loads. The tap may cause the AC disconnect to trip prematurely if the total load exceeds the disconnect's ampacity. This can be inconvenient and disrupt the operation of other equipment connected to the circuit. Before proceeding with any electrical work, it's crucial to consult the NEC local codes and a qualified electrician. Electrical work can be dangerous, and improper installation can lead to serious consequences.